So what I'm going to do, first of all, ladies and gents, is I'm going to give you a nice little tip on how to take 10 minutes of your time and summarize all of your geometry work. And not just summarize it, but have it organized. It doesn't help you have all of the tools in your toolbox, but the tools are all over the place. If any of you ladies have tried to work with a makeup set and your makeup things are all over the place, okay, you grab the first thing that gets in, that you find your hand in, and you all of a sudden try to paint your nails with an eyeliner. It's not that it won't work, it's just that you might take number one very long and number two won't look so nice. Okay? Now the gents go, okay, cool, so whatever. Okay? Ladies and gents, let's try and get our toolbox organized. You have 6 sections in grade 8 to 11 geometry. 6 sections. And each of these 6 sections have got their own special things. So I'm going to basically go and try and divide my board as best as I possibly can into my sections. Let's start with grade 8 and 9. Because you won't believe how often grade 8 and 9 maths comes into your syllabus. First of all, you've got your lines, which is your F, your U, your N, your X, your T. Now all of these, I want to say, are in your book that I handed out to you guys. It's all in there, but I'm going to just quickly go through them. The F is corresponding angles. The U is co-interior angles, or angles on the same side of the transversal line. N is the alternate angles. Now, ladies and gents, I'm going to just quickly do this and say, please remember, these have to do with parallel lines. So if you, for instance, say alternate angles, you have to specify which angles are parallel to each other. Secondly, if you want to prove alternate or prove parallel lines, there's only 3 ways. Proving that angle equal to that one, or that one equal to that one, or proving that one, those two supplementary. So please, if they ask you, prove that this line is parallel to that line, F, U, and N are the first 3 theorems you look at. The X is vertically opposite. Those 2 angles are equal. The T, I know confused you guys, but it means those 2 angles must add up to 180. So it's angles on a straight line. Okay? There I've got my basic grade 8 and 9 line geometry down. Then, ladies and gents, you also did triangles. That's the second section. Your first and basic axiom of triangles is that the interior angles add up to 180 degrees. Okay? I just quickly want to know, I use the word now called an axiom. Whom of you guys know what an axiom is? And it goes like, Number one, it's not a skin condition. An axiom is a generally accepted truth. Like, sir, what color is that lovely jacket of yours? It's purple. Can you prove that it's purple for me? Now he's looking at me and going, what do you mean prove it? Okay, guys? You cannot prove an axiom because we accept it. Now I'm going to drop a bomb quickly and say to you, how many of you guys have watched the movie WALL-E? WALL-E. Okay, those of you guys sitting behind the cameras are getting a big smile on your face. What was the name of the ship? The Axiom. Okay, it was the Axiom, right? Okay, guys, let me quickly prove that maths is everywhere. They named it the Axiom because everyone accepted that was a general truth about how life was to be lived. Ooh. It was an accepted truth. That's why they called it the Axiom. Now you're never going to look at WALL-E the same again. Maths is everywhere. Okay, now ladies and gents, let's continue down this rabbit hole of geometry. If the two angles are the same, if the two sides are the same, your base angles will also be the same. And now here comes a nice little nugget. If they ask you to prove sides equal to each other, this is the first theorem that I try and prove. If I can get the base angles equal, the sides opposite them will also be equal. Then as well, we did the exterior angle of a triangle, that the sum of the interior opposite angles is equal to that exterior angle. Those of you coming in, please make sure you get a paper. Okay? Take one for your buddy back there as well, please. Now, ladies and gentlemen, please make a note of this. Do not forget about congruency. We can ask you to prove two triangles congruent to each other. And I have asked it in the past as part of an exam paper. Prove congruency. Do not forget about it. If you have forgotten about it, my advice is go and get an old grade 9 or 10 textbook and just skim over it again. Okay? Then, ladies and gents, I'm just going to write here at the bottom quadrilaterals. Quads. Please go and revise all the properties of quadrilaterals, because in analytical geometry they love to ask it. They give you a kite and ask you questions about the kite. Then you have to know a kite, two pairs of adjacent sides are equal. The one diagonal is bisected and the two diagonals are perpendicular to each other. The sides, the angles, there's one pair of opposite angles that are equal. One of the diagonals cut two of the angles in half. Now you guys are like, I forgot a few of those. Go and revise it. Again, get a grade 10 textbook. They always have very nice summaries on there on all the properties of a quadrilateral, of all the quads. You're supposed to know it. And that is going to grade 8, 9, and basically grade 10 work. Then we go over to grade 11. Now, when it comes to grade 11, ladies and gents, we specifically look at circles. Now, here comes the shocking thing. Very few of you know what the definition of a circle is. Okay, now, you guys are going, it's a round thing. Wow. It's not exactly just a round object. Guys, the definition of a circle is, it's a series of interconnected points that are equidistant from a central point. Yo. In other words, it is a round thing that is closed and has a radius that is equal everywhere in my circle. That is always going to be your starting point in any circle geometry sum, is you're going to start by looking at the definition. That is step number one. Then only are we going to work outside to the other theorems. Now, I know how most grade 11s and 12s approach circle geometry, and that is the whole, I look at all the theorems all the time, and halfway through, I give up. Because I'm running out of time and I'm not getting through this, and I've got like another 20% of the question paper to do, and no, you know what, let me go over to the next question. It doesn't have to be that way, ladies and gents. You must learn to get your toolbox, open it, and look at the right drawer in your toolbox. Or ladies, open your vanity case and look in the right drawer to get your Q-Tex so you can paint your nails. Okay? I know something about that because in my household, I am outnumbered. We have one beautiful little girl, then there's my wife, and then we have 2 female cats and a female dog, so I'm completely outnumbered. Okay. So ladies and gents, when I study circles and when I go and I answer an exam question, I always have my theorems in 3 separate drawers. Depending on the scenario, I open a specific drawer. So the first drawer that I look at is when I'm given a midpoint or a center of a circle. Number 1, if I'm given a center of a circle, I look at radius. I look at all the radii and all the theorems that could work in with radii. So the first one, when I look at the midpoint, I look at theorem 1, 2, and 3. Theorem 1 says, from the center of a circle, if I have a radius and it's perpendicular to a chord, it will bisect that chord. And here, my gent, I've got the second way of proving sides equal to each other. The first way is using isosceles triangles. The second way is by proving that the radius is perpendicular to the chord. Then I have equal sides. Okay? The second theorem that I like to look at is then the midpoint theorem, which says the angle at the center is equal to twice the angle at circumference. Now here, I advise you to use your fingers. Okay? If your teacher haven't taught you to use your fingers, that's okay. That's why we are here today. You start at the middle, form that little angle, so go along the radii, bring it together. So you start at the middle, form it there, bring it together. You can go and practice that one. But now you've got to be careful. There's 3 variations of this specific theorem. The 3 variations are, I apologize for drawing so small. That little angle at the center is twice that angle there. Okay? I might just need to draw a little bit bigger. The second one looks like that. The angle at the center is twice the angle at the circumference. Or the last one, the angle at the center is twice the angle at the circumference. But it has to be in the opposite circle segment. So even though I go there and there, it's the angle in the opposite circle segment equal twice that angle there. Use your fingers. I know you might go, but sir, I'm a big man, you know. How are people going to laugh at me when I do this in the exam using fingers? At least you're going to get it right. You might look like an idiot, but you'll be the idiot that gets it right. Okay, guys, I'm just being real with you guys. There's no time for image. Okay, Theorem 3 is actually a corollary of Theorem 2. In other words, a special case of Theorem 2, which says if I have a diameter, the angle in the opposite circle segment is a 90 degrees. It's one of my favorites to look at and one of the favorites for them to ask. And you guys forget about that one very quickly. So there's Theorem 1, 2, and 3. Then, ladies and gents, after I've looked at Theorem 1, 2, and 3, or let me ask, Seth, when do I look at Theorem 1, 2, and 3? Say again? When do I look at Theorem 1, 2, and 3? When they tell me I've got a midpoint or a center. Guys, you don't assume, oh, that looks like the center of the circle, so I can go there. I've had many a kid come, that looks like the center, and then it isn't, and then the whole sum is wrong. We have to tell you it is a center. Guys, after I've looked at midpoints, I go to Theorem 7, 8, 9, which has to do with tangents to circles. When do I use these theorems? When you are told this thing is a tangent. Guys, please, in many of my exams, I have caught kids out where the line looks like a tangent. And then half of my grade 12s go, woo, this is easy, sir. Woo, I've got this angle equal that. Then the second question is, prove it's a tangent to the circle. And then everyone goes, oh, whoa, I've now wasted a lot of time. And then they try and salvage a situation and lose a lot of marks. So tangents, step 7, is first of all, if I have a radius and I have a tangent, the radius is perpendicular to the tangent. Where do we use this theorem a lot? In analytical geometry. Okay, now you guys are going, but I haven't done circles in analytical geometry. That's okay. But remember, because if I get the gradient of the radius, I can get the gradient of the tangent. Because their product has to be -1. Theorem 8 is definitely a fan favorite. if I have two tangents from the same point, they are equal in length. There's two things for you to look out for. Number one, if we connect them, I've got an isosceles triangle. And now even better, if I connect them to the center of the circle, what kind of a figure do I have? I have a kite. Which means if I connect this point to that point, what properties do I have? Well, it must cut that one into, there has to be a 90 degrees. Okay, those radius are going to be equal. Those angles are going to be equal. Guys, there are so many properties that, and I haven't even written all of them in for a kite. But please, 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 just pause for a moment. You cannot go and just say, oh, those things are equal, it's properties of a kite, if you haven't told the examiner that it is a kite. You have to first state, this thing is a kite because these two sides are equal and those two sides are equal. Please don't go and walk the road of assumption. Okay, I'm not going to finish that sentence. Okay. If I have a tangent, your tan chord theorem. Again, use your fingers. From here, follow the tangent, make the angle, bring it together. That one there is that one there. From this side, follow the tangent, form that angle between the tan and the chord, bring it together. That one there is that one there. Please use your fingers. I encourage you guys to use your fingers. It works. Now, after I've looked at midpoints, after that I've looked at tangents, I am going to look at cyclic quads. Why do I look at cyclic quads at the end? Okay. Guys, can I give you the tip? They never tell you there's a cyclic quad. No, you look at the sketch and you see whether there's a cyclic quad. Sometimes they do ask you to prove it is, but a cyclic quad you have to go and look for. Cyclic quad. Cyclic quad is theorem 4, 5, and 6. So theorem 4 says, some call it the butterfly, some call it the bow tie. The angles in the same circle segment are equal. Same at the bottom, those two are equal. Be careful, there's a corollary, a special case of this theorem that you guys forget about. If I have equal sides, the angles opposite them are also going to be equal. Do not forget about that little corollary, that special case of theorem 4. I expect it because you guys forget about it. Okay, I expect it because you guys forget about it. Theorem 5. Opposite angles are supplementary. Okay. Theorem 6. The exterior angle is equal to the interior opposite angle. Now, please, ladies and gentlemen, do not forget about the converses, which says for theorem 4's converse, if I have a bow tie, then it could lie in a circle. Now please don't be that idiot, and I'm saying that with a lot of respect, where on the sketch the quadrilateral doesn't lie in a circle and they ask you prove it's cyclic and you go, it doesn't lie in a circle so it can't be cyclic. I really have had that in the past. I just want to smack that kid because then I know the kid didn't study at all. They're just trying to be funny. Guys, if we say prove something is cyclic, it means that I could draw a circle around it. So the one way is by proving that there are bow tie angles equal, or theorem 5's converse, if the opposite sides add up to 180, we could draw a circle around it. Now I want to quickly ask you guys this question. Are all rectangles cyclic? Yes. Because the opposite angles add up to? Are all parallelograms cyclic? No, because we just know that they are equal. They're not necessarily adding up to 180. Now, if I look at theorem 6, it says, theorem 6's converse says, if I have the exterior angle equal to the interior opposite angle, then I could draw a circle around that. Okay. And that, ladies and gents, is all your grade A to 11 geometry, except now for quads and congruency on one board. Now I'm going to quickly, for those of you pressed for time when you study for exams, highlight a few ones that you have to know the proofs of. You've got to know theorem 1 and its converse. Theorem 2. So all the ones with stars, you have to know their converses. Or not the converse, the theorems. So theorem 1 and theorem 2 is important. Theorem 3 you don't have to know. Theorem 4 you have to know. Theorem 5 is doubly important, because we ask it quite regularly. Theorem 6 you don't have to know. Theorem 7 you don't have to know. Theorem 8 you don't have to know. Theorem 9 is doubly important. Okay? No, but I'm saying to study the proof of the theorem. Now, ladies and gents, just one last little bitty thing. If they ask me to prove a tangent to a circle, I'm always going to look to prove that angle equal to that angle. That's the only way I look at it. Not that this one can't be used, but it's not used often. I haven't seen it at all in the matric final. So this one is the one I favor if they ask me prove it is a tangent to a circle.